let's talk a little bit more about class diagrams. In particular, there are a few more kinds of relationships that you should understand when you see them. First, let's talk about aggregation and composition. The first thing to understand about these relationships is that they both indicate has-a relationships, just like the association arrow. But they're more specific than association. They typically, though not always, indicate the presence of a collection or container. So, for example, an order object has a collection of line order objects. In the class diagram we looked at previously, an association arrow was used to indicate this, but it probably should be indicated with either an aggregation or a composition arrow. So both aggregation and composition indicate some sort of collection. But what's the difference between them? The difference is that in aggregation, the aggregated objects still exist even if the object that holds them is destroyed. In composition, the opposite is true. If the holding object is destroyed, then the held objects are destroyed also. So composition indicates ownership, where aggregation does not. Look at the diagrams in this slide. A club has many members, but if the club ceases to exist, its members do not. A polygon has 3 or more points. If the polygon is destroyed, the points are destroyed also. They do not belong to other polygons. Okay, we said before that the order class in the order processing class diagram holds a collection of order lines, and therefore it would be better to use an aggregation or composition arrow rather than an association arrow. Well, which is it? Should we use aggregation or composition? If you're not sure, pause the video and think about how you'd answer that question. Ready? The first one, aggregation, means that if the order is canceled, the order lines will still exist, perhaps as the order lines for another order. Does that make sense? No, that doesn't make sense. Those order lines belong to one order, which means that the second relationship, composition, is the correct one. When the order is destroyed, the order lines disappear also. Here are a few more types of relationships, mostly dealing with interfaces and abstract classes. Abstract classes and abstract methods should be represented with italics. For clarity, sometimes underlining is used instead of italics. Interfaces are completely abstract classes. None of the methods in an interface are implemented. Ideally, interfaces should be labeled with the keyword interface before the name. Sometimes you'll see the name made italic or underlined, just like an abstract class is. In these cases, you'll have to figure out by context if what you're looking at is an abstract class or an interface. For example, if all the methods are abstract, it's an interface. If an interface inherits from or extends another interface, a traditional generalization arrow is used. If a class, either an abstract class or a concrete class, implements an interface, an implementation arrow is used. This is just like a generalization arrow, except that the line is dashed instead of solid. The last kind of relationship you see in this diagram is a dependency arrow, from the order class to the list class. A dependency arrow looks like an association arrow, except that it uses a dashed line. This is the least specific relationship in a UML class diagram. It just means that the order object depends on a list object in some perhaps unspecified way. Sometimes it's apparent from the context, but you can also label the line. From the perspective of a Java implementation, a dependency of class A on class B just means that class A has to import class B for some reason.